Here we are going to continue our work on unit conversions, and we'll do a little bit more practice before you take some time to work on the practice sheet related to unit conversions. So let's do another problem. And here we're going to try and convert 3 times 10 to the 8 meters per second into miles per hour. So this number, if you may or may not recognize, is the speed of light, 3 times 10 to the 8 meters per second. Now notice, in this case, we don't just have one set of units to convert, but two. So we're going to have to do a length conversion. And we're going to go here from meters to kilometers to miles. But then we're also going to have a time conversion. And so we're going to go here from seconds to minutes to hours. Although if you know the number of seconds in an hour, you could do that directly in one step and go directly from seconds to hours. With any unit conversion question, you always have that ability. If there's a different conversion that'll get you there, regardless of the path you take, it's going to get you to the same answer as long as your conversions are correct. So let's go ahead and try this one. So we have 3 times 10 to the 8 meters per second. First thing we want to note very carefully is that our meters unit is on the top and our seconds unit is on the bottom. And so that's going to make a difference when we have to do these conversions. So I'm going to start out with our length conversion. So I'm going to go from meters to kilometers. Now that's a conversion we did previously during the last question. But here we're going the other direction. So previously we went from meters to kilometers. Now we need to go, we went from kilometers to meters. Now we're going the other way. So meters, 1,000 meters goes on the bottom, and 1 kilometer goes on the top. Now we need to go from kilometers to miles. So kilometers goes on the bottom, and miles on top. And again, on an exam, this is a conversion I would give you. In this type of setting, it's something we can easily look up. 1 kilometer is equivalent to 0.621 miles. So if we set this up correctly, meters cancel and kilometers cancel. Now we need to do our time conversions. As we said above, we're going to go from seconds to minutes, minutes to hours. Now we know the number of seconds in 1 minute is 60. So 60 seconds is equal to 1 minute. But where do we need to put each unit? So what's different here is the unit that we're trying to get rid of, seconds, is already on the bottom. So to get rid of seconds, we need it to be on top. So 60 seconds over 1 minute. And then the same thing for minutes to hours. If we want to get rid of minutes, it's already in the denominator. It needs to be in the numerator. So 60 minutes over 1 hour. That now allows seconds to cancel, minutes to cancel. And at this point, we're left with our desired units of miles in the numerator and hours in the denominator. So once we do our calculation, we can enter all this into our calculator. We get 6.70 times 10 to the 8 miles per hour. Now, what about significant figures here? So you'll notice our starting number had 3 significant figures. And so that's what I've kept in our ending value, 3 significant figures. But what about the fact that some of our values that we used in this problem, such as this 1 kilometer here, the 1 minute, and the 1 minute here, each of those look like they only have 1 significant figure. Well, the key here unit conversions are generally exact values, especially the metric ones. Therefore, we treat them as being infinitely significant. So in other words, these conversion factors, they contain essentially an infinite number of significant figures. They contain as many significant figures as we need them to. What this means is that unit conversions do not impact the number of significant figures. And because of that, only the measured value we start with controls the number of significant figures. So that's why, even though it looks like here that some of our unit conversion numbers only contain 1 significant figure, that doesn't come into play with any of our calculations. Now, the last thing we're going to need before we finish this section and we start some practice work is to look at density. Density is the ratio of mass of an object to its volume. And the equation for density, which we abbreviate with the lowercase rho, is equal to the mass of an object over its volume. But if you need a tool to help you remember that, let's watch the following.
Lou, give me a milk. Chocolate. Sherry Coke. Lorraine, my density has brought me to you.
What?
Oh, what I meant to say was...
Wait a minute. Don't I know you from somewhere?
Yes, I'm George McFly. I'm your density. I mean, your destiny.
So how will this help us to remember density? Well, for those of you who have never seen Back to the Future, that's the movie that this is from. And in this scene, as you can see, George keeps getting density and destiny mixed up. And so we're going to use that mix up to our advantage. And when we think of density, we can think of destiny, as George is hoping here. And so once we make that connection, if we draw a line in the middle of our heart there, you can see that gives us roughly our m over v. Units for density are most commonly in the units of grams per milliliter. So at this point, you should get out the practice sheet labeled in-class exercise number 2, unit conversions, and go ahead and work through some of those problems. And at the start of the next video, I will go through some of them. Again, I will post the answers for all of them, and then we'll continue on with material.